Okay, so for number 1, remember this little trick. Domain, range, x, y. Okay? D comes before R in the alphabet. X comes before Y in the alphabet. So domain is the X, range is the Y. Right? The domain is simply the X values, and the range is simply the Y values. Okay? Notice how you had 2 in 2 places for the Y. You don't have to write it twice. You only have to write it once. Same thing with the mapping. Notice how you only write it once, but we drew 1 arrow from here and 1 other arrow from there. So you only have to write it once, but it is there. Now, when you're making a table, it has to be written twice. You got to have all those points. Now, I know some people look at this and go, well, this can't be a function. Look how messy it is. You know, we don't know what it is. It could be something like this, you know. Not necessarily it is, but since no x's repeat, all right, it is a function. It is yes. On number 2, all you're doing is plugging these x values in here. So all these values, you're just plugging in right here and crunching the numbers. When you do that, these are your ordered pairs. You graph it. The mapping looks just like the ordered pairs because there's no doubles. It's just with arrows instead of a table. Okay? The domain, this is a little bit different for you guys. The domain is all, we write it this way for you guys, print out all real numbers. Okay? Domain range. It's going left and right forever. It's going up and down forever. Am I a function? Okay? This is the vertical line test. So you simply do this a couple times. Yes, it is. Yes, it is. No, it's not. Yes, it is. No, it's not. Okay? And then, if you can't do this just by memory, then just real quickly do this. And then take your finger and kind of go, okay, -2, 9. -2, 9 will be up here. That's quadrant, 2. So it's 1, 2, 3, 4. All right? So 1, 4, that means go right and up. 4, -1 means right and down. So quadrant 4. 4, -5, same thing, quadrant 4. -6, -7 means go left and down. 3. -2, 9 means go left and up. 2. Okay, is it a function, yes or no? All right, so we have 0, we're just looking at the x values. 0, 3, 4, 6, no repeats, yes. 1, 3, -4, 2, no repeats, yes. 1, 3, 3, and that makes it a no. If the x's repeat, it's a no. So apparently on yours, I don't know why there's a difference, yours has a 2 here, which would make this a yes. But, going over it, if it was a 3, it would be a no. Okay, this one, no repeats, yes. This one, you look and you go, hey, I got 3, 5, 8, 11. There's no repeats. But yes, there are. Because there's 8 and 5 and 8 and 8. So if you were like this, not mapping, you would have repeats in the x, so it's a no. Number 4. Again, all you're doing is taking these and plugging them in right here. Now, what you've got to do is be careful. If you're plugging this in the calculator, then make sure you're careful, because when you put, like on this one, -2 plus 2. Okay, you got to be careful about that. It's not times, it's not a big deal, but you could put parentheses here. But definitely, if you're writing it out, put the parentheses, because a lot of people just pop -2 in here. It's not. This says the opposite of what x is. So if x is a negative, it becomes positive. If x is a positive, it becomes negative. And when you graph it, you get a negative slope linear equation, which makes sense. y-intercept is at 2. That's where we begin. And our slope is -1. And that means down 1, right 1, down 1, right 1, down 1, right 1, up, left, up, left, up, left. Like a staircase. All right? And remember, it's a negative slope, and it should be my name going downhill, and it is. Now, this right here is more the same of this. You're literally just plugging these x values in and getting y. Okay? We already did this one in the table, -2, 4. We already did 1, 1. That was just copying. -1, 3, you already had that one. And you already had this one. The only new one you really had to do, oh no, they were all the same thing, just in a different order. So you already did it. It's just a different way of writing it. But what you do need to realize is these go in here. So you say 2 equals -x plus 2, and you work backwards and solve for x. Which means you have to subtract 2, divide by -1 every time. And those are the answers you get. Okay. Now what you're doing here is you're going, remember, these are all x values. So you just go to x of 0 and say, where does it hit? 2. X of 2, where does it hit? 0. X of 4, where does it hit? 2. Now this is backwards here. This is find the value of x if y, remember this is y, is 0. So if y is 0, that's right there at 2, 0. Same thing over here. If x is 0, y is 0. If x is -2, y is down there. This is counted by 2s. That's counted by 2. That should be, yeah, so that's -2. This is counted by 2s. And if x is 2, y is 2. And then going backwards, and that kind of just is the opposite of this one. If y is 2, what's x? 2. Oopsie. Okay, the board goes up. All right. Number 7, more of the same. If x is 1, where's y? 6. If x is 3, where's y? 2. If x is 5, where's y? 6. And this is going backwards. If y is 2, what's x? 3. Same thing over here, more of the same. -1 gives you -2. 0 gives you 1. 2 gives you 1. And if y is -2, where is that? -1. That should be a negative here. My mistake, that should be a -1. Alright. On these, you're literally just plugging them in, but you've got to be careful where you're plugging them into. What you got to pay attention to is there's an H, an F, and a G. So this means plug 5 into H. That's why we have -2 times 5 plus 3, which is -7. This says F, so you're going to plug it in here. So that's why we have 2 times x cubed. Now you got to be careful. That -3 cubed becomes first. So it's -3 times -3 times -3, then you double it. This one means plug it in here. Here. So the cube root of -8. And you can do that on your calculator. Okay? You just hit the 3 button. I showed a bunch of you people. Okay? You hit the second key, and then you hit the little key on your calculator that looks like square root but with an X up there, and then you type in -8. Enter. And when you do that, you get -2. Okay? Same thing for this one. You just type this in your calculator. Notice it says G, so it's a cube root of -27. Same as 3. Don't just see the negative and go, oh, no solution, because that's only for square roots. Technically, it's for any even. Square root, 4th root, 6th root. For odd roots, like 3, you can take it. Okay, F of 4 means plug 4 into the F1 right here. You cube the 4 first to get 64, then you double it to get 128. G of 64, again, just plug that in your calculator. The cube root of 64 is 4. 4 times 4 times 4 is 64. Okay, this you're just crunching the numbers. Okay, so you're plugging these numbers in and seeing what you get. So if you plug -2 in for F, you get -16. If you plug -8 in for G, you get -2. And so you want to use one of the less than symbols, because -16 is less than -2. Okay? You plug this into G, you get -3. You plug this into H, you get 19. Well, which one's bigger? Clearly 19. So you're going to do A and C. Now, careful on piecewise. It looks a lot more complicated than it is, but it's really not. You look at this number right here, and then you look at these two statements. You look to see, is -3 greater than 1? No. Is it less than or equal to 1? Yes. So -3 gets put in there to give us -9. F of 2. Well, we look at the 2. And we ask ourselves, is that greater than 1? Yes. So you plug it in right here. 2 times -4 is -8. More of the same, just one step further. Now we're doing two things. So first we're going to plug -3 into G. That's right here. Okay? That's right here. That's right here. So -3 into G gives us 12. We're also going to plug a 3 in to F. Right there. So 2 to the 3, which is 8. And then at the last step, we add those two together and you get 20. Okay, F of 4. We're going to put the 4 right there. Minus G of 2. That means we're going to put a 2 here and here. 2 to the 4 gives us 16. That's one number. We leave it alone. We crunch our numbers here. 2 squared minus 2, which is 4 minus 2, which is 2. And then the last step, we finally subtract the 2 and get 14. Number 20, we're plugging -14 into the absolute value because it says H. We crunch that, we get -6, absolute value is +6. And then all we're simply doing is adding 1 to get 7. Okay, function families. 21's linear, it's y equals x. This is right out of your notes. 22 is exponential, y equals a to the x. I know a lot of times we wrote 2 to the x. That's okay, but it could be that, or it could be, the k. So we just use the letter a, generically. 23 is quadratic, x squared. 24 is square root. 25 is cubic, x to the 3. And 26 is absolute value, prison bars. All right. This is just matching. Determine the type of function. Okay, cubic, you're looking for a 3. That's right there. This is square root. So that's F. Right here, this is x to the 1. X to the 1 is a linear equation. So we look for the word linear, which is C. We have a 2 here. 2 means squared. That means quadratic. That means parabola. That's B. Absolute value bars? E, absolute value. Notice here, where is my x? It's up in the exponent. So that's D, exponential. We have a repeat. Since we have a 2, that's B, quadratic. And this one is linear because we have a 1 here and a 1 here. X to the 1. More of the same. Graphing a line. Plug these numbers in right here, but be careful when you do it because -2. And again, you can check this. What's my B? Right here, my y-intercept. What's my slope? -2 over 1. That means down 2, right 1, down 2, right 1, down 2, right 1, up 2, left 1, up 2, left 1. So you can graph it that way and confirm with your table. Now, state the y-intercept above as an ordered pair. Well, it should be 0. Since it says ordered pair, you should technically write it as 0, 1, but you could just say 1. I would accept either one. What's the domain range? Again, this is how you'll be writing it later, but for right now, we just say all real numbers. If it's a line, but if it's a parabola, it's going to be different. Okay, it'll be like a parabola will be all real numbers for the domain, but the range will be greater than or less than. Okay, x-intercepts. Well, you're just looking for where it crosses the x-axis. There they are. -4 and 0. You can also write, obviously, -4, comma 0, and 0, comma 0. That's fine too. I would accept either one. The y-intercept is 0. If you write 0, 0, cool. The domain. Again, you guys write it this way, all real numbers. All right? The range. We write it differently. It's going to be y is less than or equal to 4. Because remember, here's the roof. It helps if you draw the roof or draw the floor in. Okay? And say, where is it? It's at 4. The ceiling's at 4. That's how high the ceiling is. Am I going above or below? Well, it's a ceiling, so below. So less than or equal to 4. It's a maximum at 4. Technically, you should write the equation y equals 4. Not just 4. You should write y equals 4. Now, this one printed goofy on yours, so I don't know why. This was down here and this was down here, so it's kind of backwards thinking. This is just saying, as x is going to the left, towards negative infinity, what's y doing? It's going towards negative infinity. It's going down. And this says, as x is going right, towards positive infinity, what's it doing? It's going down towards negative infinity. Okay? So just saying, just think about it that way. Left, what's it doing? As it goes right, what's it doing? Now, the increasing interval, where is it going up? Okay? Well, it's going up between negative infinity and -2. But this part you don't have to worry about because we didn't really talk about that. So don't worry about that. Same thing on this one. We're going to skip this part. Okay, x-intercepts. There's 3 of them. -3, 0, and +3. Y-intercept, since it goes to the origin, it's both. The domain, how far left and right, that's all real numbers. How far up and down, all real numbers. So linear and cubic function is always going to be all real numbers for both, because it's going left and right forever, up and down forever. Maximum, minimum, they're not for one. It doesn't say section shown, so I want to talk about that. So the max is right here at, what, -212? All right? And then the minimum is down here at -10, looks like. Okay, so it does have a maximum minimum overall in the graph. Same thing, just a little bit different here. As it's going left, it's going down, negative infinity. As it's going right, it's going up towards positive infinity. So, as it's going left, the arrow's going down. As it's going right, the arrow's going up. Okay. Kind of hard to see here. Some of these are written in. This is +3, +5, +7, +9. Okay? This is a quadratic function. If you look further, this is 2, 2, 2. So it is going up the same amount on the second level. The next one is quadratic also. It's going up by an increasing amount. This one has that mirror image here, but the same amounts. so it's absolute value. This one is times 3, times 3, times 3, times 3, so it's exponential. This is plus 2, plus 2, plus 2, linear. And this is minus 2, minus 4, minus 4, minus 2. That's not linear. That's a mistake. Okay. What did you guys put for that one?
Linear.
2, minus 2, minus 4. It's changing though.
Oh, is that so? It's probably an exponent. No, but it's still negative. Like, if it didn't change, if it changed like signs, then.
Oh wait, hold on. My bad. My bad.
Whoa, there.
I just realized what's happening here. This is skipping some numbers. It went 1, 2, 4, 6, 7. So it was missing 3 and 5. So because of that, yes, it is linear because it is going down by 2 every time. It just skips some. Okay, 32. All you're doing here is, again, plugging these in right here. You're plugging these in right here. Now, hint, use even numbers because of this 2. If you do numbers like 1 and negative 1, you get fractions. If you use 2 and 4, they cancel. So obviously the first one is a parabola. It's also a sad parabola. So when you graph that, that's like here. Okay. The G is a linear equation with a negative slope. So when I write my name on it, it is going downhill.
Wait, then how is it a parabola?
The first one's a parabola right here.
How?
What do you mean how?
It can go up.
It's got a 2 right here. It's quadratic.
Oh. Okay.
Okay, so do the functions intersect?
Yes, sir.
Yes, they do. So when you're looking where they cross, this is the easy one. That's 2, negative 2. Okay? But the second place they cross, you'd have to estimate. Okay? And it looks like approximately 0.5, 1.5. Approximately. It looks like, halfway here and up 1.5. That's just an approximation. If you put 0.4, put 3/4, it's just an approximation. Okay, what is the y-intercept of g of x? Well, that's at 1. And we can get that from our table right here, 0, 1. That's the y-intercept. The y-intercept of this one is at 0, 2. So we got our intercepts. Okay. Y-intercept is 2. The domain of f of x being, remember that's all real numbers, parabola. The range, we don't write it this way. So, the range. Here's my ceiling, right? So it's y is less than or equal to 2. The domain, we write it this way. And the range of the line is also forever. It's everything. Describe the end behaviors of f of x. F of x is the parabola. Well, both of them are going, the parabola is going down. So they're both down. It has a maximum at 2. And you can also write 0, 2, that's fine. And I said don't worry about that part. Okay, 33. You're just plugging these numbers in. Again, these numbers are going right here. These numbers are going right here. You have an exponential and a linear. So your exponential is the one that rides out here and goes up like so. Your linear, you can see where that is. Okay? Do the functions intersect? Yes. Yes, they do. If so, where? Right up here, 2, 4. What is the y-intercept? 1. Okay, it's right here. What's the y-intercept of the line? That's down here, -2. What is the x-intercept of f of x? There is none, because it's never going to hit the x-axis. What's the domain of the line? All real numbers. What's the range of the line? All real numbers. In behaviors of f of x, that's the exponential. As it's going left, okay, as it's going left, it's approaching 0. It will never hit 0. Okay? And as it's going right, it's going up to positive infinity. Okay, this one. All you're doing, it says, here's one company, here's the other. X is the number of widgets. Well, the first part says, here, I'm giving you 10,000 widgets. How much is it going to cost me? So you plug in 10,000 here, you plug in 10,000 here, you crunch the numbers. Obviously, company B is way cheaper. Even though company B has a bigger number here, since this number is so much smaller than that, at least it means cheaper. The initial cost is more expensive, but the rate is cheaper, and it works out in time. Now, how many widgets can the company make if I just had $425? Well, you put $425 in for Y in both of them. And then all you do is subtract 2.5, divide, and you get 9,825. And again here, you subtract, you divide, and you get 14,510. So obviously, the cheaper company produces way more for the same amount of money. All right, all you're doing here, literally, is just putting the 12 in and the 15 in right there. Because it says X is months. So when you plug 12 in, you get $8.17. When you plug 15 in, you get, is that $18 or $8.42? Okay, listen up. This is very important. We didn't cover this as completely, so just remember. First off, if you just look at this, that's a negative slope. This is a positive slope. This is just a mess. Okay? There's nothing there. There's no correlation. But not only the slope, if I asked you, about numbers, it goes between 1 and -1. Listen carefully, please. The closer you are to 1, the stronger the correlation. So, if I said I had a correlation of -92 and 0.92 and -0.73, which one has a stronger correlation? No. Closer it is to 1 or -1.
Wait, what is the other one?
-0.92.
Oh, no. Oh, 92.
Okay? So, for example, this is very important. If I had this line, you might want to listen. This is important for the test. This would be an example of -0.92, maybe, and this might be an example of -0.73. So the closer it is to -1, the closer the stuff is to the line. The closer it is to 0.5, halfway, the more spread out it is. Okay? That's very important. So besides negative and positive, you have to be able to look at numbers. You're not going to have to calculate numbers. That's later on. But you do have to look and say, if I had to choose between two numbers, like 0.7 and 0.9, 0.7 is going to be more scattered. 0.9 is going to be more together, tighter to the line. Okay, so 37, yes, there's some data out there. That's kind of an outlier. Most of our data is going like that. It's negative. And it's decreasing. Most of our data here is on that line, which is positive and increasing. Now it says here, using the line of best fit, find the range for a wife's age if the husband's between 60 and 65. So all you do is basically go boom, boom, okay, and find out where that would be for the wife's age. So somewhere in there, like 55 to 65. Okay? The data would probably be there. That's all you do. You just kind of look for the intersection. Okay, 40. Okay, you have the equation, the function, 2x minus 1. Okay, it's already done for you. If it wasn't done for you, you plug them in. You got your line. Then the inverse. All you do is flip-flop the x and the y. So remember, the word inverse just means flip your x and y. That's all you have to do. So all the y's become x's, x's become y. It's upside down day. It's backwards day. Up is down, black is white, morning is afternoon. Okay? You just switch it. And all it did is ask you here to graph both lines. And that's what it looks like. So you have your original function here, and then you have your inverse function there. And that's it.